Video, we're going to look into how to design a logic circuit to perform basic addition. So the circuit that is used to perform this binary addition is called a binary adder. So let's look into a simple case. We have a number 1, 0, 1, 1. We need to perform this addition here. So the way we do it, we have done it is we took one bit at a time, which is we took this 0 and 1, we added, becomes 0 and 1 becomes a 1, so we write a 1, carry forward a 0 to the next bit is 0, then we take the 0, add 1 plus 1 becomes a 2, so we write 2 as 1 followed by carry of 1, this comes down and we write as a 1, right? So now if I take this number and write it in something like A's and B's, so I have a number A1, A0, I have B1, B0. Now I need to add it, right? My sum is going to be 0, S1. Now I'm writing this as the carry that 0 propagated is 0, and the carry propagated from that is C1. I will write it down as Cout. Alright, I just took a basic addition and wrote it in terms of A's and B's. Now if we look into here, if we take any one common bit, right, I'm taking this common bit here, one bit, and if we try to design a simple logic block for it, I have inputs. My input is A, the second I have my input B, and my output coming down is sum, my S, and there is another input coming from the previous stage, so I'm going to write it as C in, and there is an output generated carry for the next stage, right? I'm going to write it as C out, and we'll call this addition. This is your fundamental binary adder. So let's look into here how to design this simple function here. Okay, so what I did is, just to save time, I have pre-drawn the design, a truth table here. So let's write the truth table output first. So what you could do here is look at the first row here. The first row is inputs 0, 0, 0, followed by 0, 0, 1, followed by 0, 1, 0, and so on and so forth. The simplest way to write this value is add the zeros. Consider this is a binary decimal 0 plus decimal 0 plus decimal 0. When you add these three, what is the decimal equivalent? 0. Followed by, consider this as decimal numbers, for instance. 0 plus 0 plus 1 becomes a 1. Then followed by 0 plus 1 plus 0 is 1. Followed by the next row is 0 plus 1 plus 1. Decimals. Consider this as decimals. 1 plus 1 is 2, so we write it as 2. Followed by 1, followed by 2, followed by 2, followed by 1 plus 1 plus 1 is 3, right? So we write 3 here. Once you write it, the output, the best way to write it is take that 0 and write the binary equivalent of 0, which is 0, 0, 0, 1, 1, 0, 1, 1. Is that right? So far so good? No, that is wrong. My decimal 1 is 0, 1. Next one, decimal 1 is 0, 1. Decimal 2 is 1, 0. Decimal 1, 0, 1. Decimal of 2 has a binary equivalent of 1, 0. Decimal of 2 has a binary equivalent of 1, 0. Decimal of 3 has a binary equivalent of 1, 1. So from that, if you take the K-map and if you simplify the functions for S sum and carryout, my carryout will have a formula something like AB plus Cin times A plus B. and my sum is going to have a formula of A XOR B XOR Cn. So again, just for you to know, this symbol stands for XOR. Okay, now if you have, how do we, once we have this 1-bit full adder, 1-bit binary adder, how do we perform this 2-bit addition? So we have 1 bit here and 1 more bit here. So all what we do is this: we take 2 1-bit adders and I'm just drawing the symbols here. I'm not doing anything else right now. I'm drawing the 2 symbols for 2 1-bit adders, right? And look into the true block on the left page. We have on the top inputs A and B. So my first bit has inputs which are A0, B0, and my output sum 0. Similarly, my second bit has inputs A1, B1, sum is S1. And do we have a carry from the previous stage here for bit 0? The answer is here, the answer is no. So we give a 0 here. And the carry coming from C0 is going, if you see here, from bit 0, the carry is coming in and going to the next stage, right? So we take that carry, connect it to the next bit, and the carry coming out from C1 is going down as Cout. So you write that as Cout. That's it. So if you have a 4-bit adder, all what you need to do is combine 4 of them together to get a simple adder. Now let's look into something different. How do you do subtraction? Subtractor. Subtraction, what we did, A minus B, earlier what we did was A plus 2's complement of B is what we did, right? So 2's complement of B is nothing but 1's complement of B plus 1, right? So all what we do is, if we have basic adder, if we write A, B, we have this simple design here, my Cout, sum, and my carry in. So all what we need to do for subtraction is this. This is quite simple. So instead of a B, do not give a B, but connect it through an inverter and give B bar, and my carry in, instead of a carry in, give a logic 1. So that becomes a simple subtractor. A plus B bar plus 1 gives you a simple subtractor, and that is how you design a subtractor.